Hello everyone, good afternoon. So good luck for tomorrow's exam first of all. Second of all, we're gonna revise the whole of Unit 2 Physics IAL Edexcel International. So basically guys, this is just a quick something to look at before you start papers. Do as many papers, look at the mark scheme, memorize the mark scheme. Make sure you read the questions very carefully. And if you saw this video, taught you don't know something or you're not unsure about something, just go back to your book or refer to YouTube videos and everything will be all right. So first of all, let's start with wave properties. So we have amplitude, which is the maximum and minimum displacement. So the distance here and distance here, obviously it's a distance measured in meters. Then we have frequency, which is the number of waves per second. So if you have like this in an oscilloscope, you count each one per second, and then you say the frequency. So frequency is given by 1 over time period. So time period is a time taken for one complete wave to oscillate. Then we have wave speed, which just says how fast a wave travels, and that formula is frequency times lambda. Lambda is the wavelength, and it's a distance between two identical points on a wave. So it could be a peak to a peak, a trough to a trough, or any identical point on a wave. It would always be the same thing. Then you have two kind of waves, so that's longitudinal and transverse. So longitudinal has parallel oscillations to the direction of wave travel, like sound, and then transverse has perpendicular oscillation to direction of travel. Transverse could be EM waves, so electromagnetic, like radio waves, microwaves, all of those, and then longitudinal could be sound waves. So again, comparison between these two are really important. Make sure you know it. Transverse always needs a medium. Longitudinal, not always. Transverse has peaks and troughs. So peaks are the higher ones, troughs are the lower ones. Longitudinals have compressions and then rarefactions. And then speed on both of them depends on the material. Then we have standing waves, which are formed by interference between two waves traveling in opposite directions. Then they give you antinodes and then nodes. So nodes are these parts, so no movement or minimum displacement. That's how I memorize it. And then antinodes, this kind of looks like an A, so it's on top of the A, so antinodes. And those are the area of maximum displacement. It could either be down here or up there because we're saying displacement. So wavefronts are lines of constant phase, so like this, so their distances are the same from wherever you want to calculate. Then coherent waves are waves of similar amplitudes and frequency with constant phase difference. Make sure you memorize this comes up very, very often. Then we have path difference, which is the differences in distance. So if you have two waves, you want to see where they collide, and that is the path difference. It's obviously measured in meters because it's a distance, and if you have n multiples of lambda, so like 1, 2, 3, -1, whatever, then that would give you constructive interference, and the amplitude will add. But if you have n plus half lambda multiple, that means 1.5, 2.5, 3.5, then that's destructive, and the amplitude subtract. So basically here I have a better explanation. So destructive is when they're moving in opposite directions, and as you can see, if they add, they give you minimum displacement, so their amplitudes are reducing. But here, since you have the same amplitude adding, the amplitudes double because they add. So basically that is constructive interference. Then we have phase difference, which is actually related to path difference, and it's the path difference over lambda times 360, and it gives you the difference in the angles that which waves collide in, so like here, this part. And then it's usually in degrees or radians because again it's a phase difference, so it's the angle. Then we have speed of the string. Don't worry, you have the equation on your data booklet, which is tension over mass per unit length. Make sure you actually do mass per unit length, not weight, and then tension is like the force times the distance. So it's V equals radical T over mu. Intensity, so as you can see in the lamp here, it depends on the power the lamp has and the area it is actually on. So this is the area and this is the power, so therefore power over area gives you intensity. Then we have refraction and total internal refraction. So change of speed when waves enters new material is refraction. So basically, if you have like a glass, the wave would go faster in air than it would go on the glass, so it would get closer to our normal. So this theta would be smaller than this theta. And the opposite thing again, if it's going from a more dense to less dense, is increases the speed because it's easier to travel. Then you have refractive index, again given in the data booklet. That is N is C over V, no units because it's a ratio. And then C is the speed of light. Again, this is also given on the data booklet, which is 3 times 10 to the power of 8 meters per second. And you compare it with the material you have. You either use this law or this one. Usually use this one just in case. So this just gives you the angle you have in your first medium, and then the refractive index of that medium, then refractive index of second medium, and the angle of second medium. You could rearrange it to find anything. Critical angle is sine C is equals 1 over n, and critical angle is basically if you have like a object like this, and if the critical angle is 30, so here if you do at 40, if you have an incident ray at 40 degrees, because critical angle is less than the angle of incidence, it would totally internally reflect, meaning it will not come out of the shape basically, instead of coming like this. So for total internal refraction, you need two properties. So one, it goes from a more dense, so glass to air, or water to air, or oil to water, whatever. And then your critical angle should be less than the angle of incidence. So polarization and diffraction. Plane polarization is basically only transverse waves could do it, because transverse waves have different directions. So it should be perpendicular, so it could be up and down. So up, down, left, right, all of that. And then you plane polarize it, so you restrict the direction of the wave travel or wave movement. So here we have up and down and left and right. We plane polarize using using a filter, and we get one movement. So reduces intensity by 50%. Then we have diffraction, which is spreading out of waves when passing through a slit. It could be a slit like this. That the differences between these two blocks indicates how these spread out. So if I have very, very open blocks, sorry, that's not very, very open. So then it would be straight lines until here because it fully passes, and then it would bend here. But then if I have a really, really small, then it would have more diffraction occurring to it. Then we have experiments, which we use diffraction gratings, and then we have a laser, and then we incident it, and then we calculate the distances here, the n here, and all of that. So this is the equation given in the data booklet, which is n times lambda d sine theta, which sine theta is just this theta here, so how much your angle is basically diffracting, and that depends on which one you're finding. So that's your n. So are you finding the first one, or are you finding the one next to it, or the one next to it, or the one next to it? So wave particle duality is basically talking about how electrons are similar to waves, and waves are similar to electrons. So electron diffraction proves that electrons have wave-like properties, and the de Broglie's wavelength is just how they proved this. Then we have photoelectric effect, which is photons have emit energies, which is h times f this time. And this is again the same thing, just trying to say that the waves have electron-like properties. So work function is the minimum energy required to remove an electron, and threshold frequency is the minimum frequency required to remove that electron. So basically, if you have something like a metal, and then you have some light incident on it, each one of those light rays emits an electron, and that's what we're measuring here. So we have an equation, which is h times f is your threshold frequency, is your work function, plus the kinetic energy released, which is how fast these just come out. So if your kinetic energy is minimum, then the electron is just freed. It will not move, okay? And then you could convert electron volts to joules, which is 1 electron volt is 1.6 times 10 to the power negative 19 joules. Again, this is given in the data booklet, so you do not need to worry about it. Also notice that this 1.6 times 10 to the power 19 is the charge on an electron. Okay, I cannot even read my own handwriting. I think this is atomic line spectra. So photons are a discrete packets of energy. Again, the photons are these emitted. They have a constant energy. Electrons move between discrete energy levels. In chemistry, we call them orbitals. They're like this. In physics, we call them just like orbitals again, but like we have them drawn like this, and then this is your ground state. And if I have an electron here, depending on the energy, it would go here, 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 and then it would come back. And then when it comes back, it emits that little photon, which is the discrete package of energy. Usually it's also viewed as light. So energy of a photon emitted or absorbed could be calculated by E equals hf. Again, h is given as Planck's constant, is 6.63 times 10 to the power negative 34. Current is the rate of flow of charge, so we have the quit formula, which is quit, so Q equals IT. In a triangle, obviously, so you could compare. And it's basically rate of flow of charge. Charge is the Q. Voltage is energy per unit charge, so energy per charge. Resistance is opposing current. So we have V equals IR. If you rearrange it, you get V over I. Ohm's law states that voltage and current are proportional, so only if temperature is constant. So if that happens, you have an ohmic behavior, so your graph of VI is looking like this. If not, you could get looks like S. Yeah, you could get things like this, which is just a diode. This is just a wire or like a resistor. But then if you have memorize these, because then you have it for LDRs and thermistors. So basically LDRs only allow one direction, and then thermistors, I'm not sure, I need to look back into this, but make sure you know this. Circuit rules, so in series you have same current and voltages add. So basically if I had something spreading out here, it would be the same across everything. So then R total is R1 plus R2 plus R3 until you get to the last one. And then in parallel, you have difference because of this junction. So basically, if you have like 3 here, maybe 1 goes here, and then 2 volts go there. So then you get 1 over RT is 1 over sum of the R's, which is your resistance. Make sure you guys could prove this. So here we have V equals IR, V equals IR again. So we're saying that we're saying that the current is the same everywhere. So we just add the R's. But then here is kind of the opposite thing. So make sure you can prove it, because it says like how, deduce, whatever. Power plus energy. So we have some equations you need to learn. Some equations are given. So PIV, power equals voltage, work done, voltage, current, time. Power is I squared R. Remember this by saying twinkle twinkle little star, power equals I squared R. And then again from this one you could get to V squared over R, because again V equals IR, so you can move back and forth with these equations. Resistivity is resistance times resistivity times length over the cross-sectional area. So if I have something like this, make sure you only calculate the cross-sectional area. So do not times it by the length, because that's what most people do. And resistivity is given in the formula, in the equation, sorry. So drift velocity is basically how fast that electron moves in your wire. So you have current equals number of electrons times their charge, given in the data booklet, both the equation and the charge, which is 1.6 times 10 to the power negative 19. And then you calculate your drift velocity if you have your cross-sectional area. Then we have potential dividers. They're used in LDRs and thermistors to basically choose how much the varying voltage output is. So it's based on a ratio of resistances. So if you have V out, that equals the V in times the resistance you're searching for and the sum of the resistances. This is very, very, very important. So make sure, sorry, I thought it was a highlighter. So make sure you know this. Then we have EMF and voltage. Electromotive force is obviously bigger than voltage because it's the energy per charge from the source. So you also have that like little mini internal resistance, which is like the internal resistance that the battery has. And in some cases we need to graph it. That comes very, very often. So again, this is your MX, and then this is your C, this is your Y. Make sure you know how to draw it, and then your gradient is going to give you a negative because it's negative IR. Make sure you know that electromotive force is bigger than the voltage, and that's the equation. Let me check if it's given. That's not given, so you need to know. But as long as you know the EMF is bigger, then you know the bigger minus something is going to give you the smaller one. Then you have two types of current, which is alternating and direct, so AC and DC. DCs are batteries, and then AC is like house. Then we have thermistors and LDRs. So both of them, as you decrease the resistance, then you must have higher temperature or higher light. So LDRs are light dependent resistors, and thermistors change their resistance based off the temperature. And why that happens is if you have more temperature, if you have more light, then you have more kinetic energy. More kinetic energy means you have more electrons, more movement in your wires, so you would have lower resistance. Good luck, everybody. You've got this. Make sure you do as many past papers as possible, and yeah, best of luck.